Hello, welcome again to another video. So now we'll be doing example 8 where we're trying to calculate the electric field. Right, so this is one of a few classical examples where you can use a formula straight away. Right, so in this case we are given a charge. It's a positive charge. You know what that means? It means it has excess protons and less electrons, right? It has more protons than it does have electrons. And then it's in a uniform electric field of that magnitude. So basically we're given this, given the charge Q, right? We use smaller q in this case, and then times 10 minus 6 coulombs, right? And then the electric field is given as 600 newtons per coulomb. Remember what I said? This is the same as this, right? So now we are asked to find the force acting on the charge and also determine the direction of this force. So let's get to it. You can say for A, if we want to find the force acting on the charge, we have to obviously relate the electric field and the charge, which is the information that we're given. And one formula that can do that for us is E is equals to F over Q. Or some people or textbooks write it as E is equals to F over big Q. So this Q could have been this one or the smaller one. It's up to you. So now we want force. So we can make force subject. We can say F is equals to Q times E, right? And then from there, we can substitute and find our answer. So we know that Q is 4 times 10 to the power minus 6, and that E is simply 600 newtons per coulomb. Okay, don't know what's happening yet. We have 600, right? Then from here, we can find out. I get that our force is 2.4 times 10 to the power minus 3 newtons. So here there's no specific direction. You can't say north, east, south, west, left, right, up, down in terms of the direction of the force. However, we do know for a fact that this force, since it's from a positive, since the charge is positive, right, so we can confidently say that this force will be in the direction of the electric field. Why? Because the charge is positive, right? So we say force will be in the same direction as the electric field since the charge is positive. So another way of looking at it, since we know that force is a vector, so we have this equation, right, that says F is equals to the one we just used actually, Q, and then you see those arrows on top of F and E. They indicate that these two parameters are actually vectors. So what that means is if Q is positive, F will be some value times E, right? And ultimately F will be positive, suggesting that they are in the same direction with E. However, if Q was negative, F would be negative the value of E. This suggests that F is in the opposite direction to E, right? So that's why we can confidently say that since the charge is positive, F would be in the same direction as E, right? Or the electric field. That's how you think about it. And then lastly, another way to think about it is usually, right, a positive charge it more or less behaves like a leaf. If you've ever seen a leaf, it moves with the wind. So if you have a positive charge, it will be in the same direction as the electric field. On the other hand, a negative charge would want to go against the wind, right? So it moves opposite to the field, right? That's the main difference between a negative charge and a positive charge, and how that would have influenced the answer to our question B, the direction of the force. So ultimately what that means as well is, if let's say the charge Q was negative, then we would be sure that the force will be in the opposite direction to the electric field, right? Because it's a negative charge. That's all there is to it. All right. Thank you very much. I'll catch you on the next video.